Hello everyone, I am Shipra Prakash. I am studying at Indian Institute of Technology, Delhi at India. Currently I am doing my masters there and I am working on my master project Evolution of Bone Electromechanogram as a low-cost substitution of DEXA for osteoporosis detection. I am feeling very privileged to show my work in this international platform. Professor Suresh Bhalla is my supervisor and Dr. Shashank Srivastava is my co-supervisor. This is my presentation outline where I give some introduction and I give some literature that I reviewed. After that, the research gaps that I found and my research objectives. After that, I show my work on development of BEMG and the methodology involved, the observation, and I will conclude with some remarks and also give some future recommendation and references. Starting with the structural health monitoring, it is a periodic monitoring of structure from safety point of view. Since damages lead to a progressive failure of a structure from minor damage to moderate damage and to then severe damage. So we need to capture this damage at a very minor age. The technique involved in the structural health monitoring is the EMI technique. It stands for electromechanical evidence techniques, that is first invented by Liang et al., which uses piezo-ceramic materials. PZT stands for lead zirconate titrate as a sensor, direct effect, and an actuator as a converse effect. We all know human skeleton is a very excellent structure. It is a supporting framework of our body. Long bones plays a vital role in locomotion. They support our weight against the force of gravity. After studying about the bone material, I found that it exhibits structural properties, that is mass, stiffness, damping, modulus of elasticity, Poisson's ratio, as any other civil engineer infrastructure, civil engineering in building has. So these are very exceptionally suitable for detection of physiological damage deformities, employing the advanced EMI technique and piezo materials. So extension of the structural health monitoring concepts and techniques to the biomedical subject is known as biomedical structural health monitoring. I am dealing with the artificial bone, femur bone of human for this project. This is the literature that I reviewed in which the co-supervisor, my, my co-supervisor Dr. Shashank has done a work in which they developed a non-bonded piezo sensor for the monitoring the decay of human bones experimented on artificial PVC bone. So they are capable of successfully identifying dynamics of bone structure. At the same time, the NBPS can detect degradation and the damage in bones. They also show some results by doing the FE modeling, and they found that the influence of skin on conductance signature was also additionally investigated. The model is a validation against the experimental results. This is the work and the experimental setup that did by the Shrivastava, in which they in which the experiment has been done on the bone, keeping the bone on a platform, showing the boundary condition as a free condition, and in the left right peak the digital multimeter and the electric stain gauge is attached to the clamps to clamp the non-bonded configuration of piezo to the bone has been used. So it is a very complex system. We can show that we can see here that it's a very complex system. This graph shows the observation made by Srivastava in which the piezo in non-bonded configuration can easily detect the difference in osteoporosis and the healthy bone. The blue one shows the conductance signature of healthy bone and the red one shows the conductance signature of osteobone. We can see that the shift is there, the rightward shift or leftward shift is there, vertical shift is there. That can show that the NBPS is capable of detecting the osteo condition and the healthy condition in the bone. So my research objective according to the literature I reviewed is that I want to develop an improved NBPS non-bonded piezo sensors configuration for biomedical structural health monitoring. Later I addressed it as a bone electromechanogram. I studied the changes induced in the EMI signature of NBPS clamped on the bone, and in three different torque ranges. I for clamping I eliminated the use of electrical stain gauges and digital multimeter. I used a torque range that is very easily available in the market, and I started giving the torque from 3 Newton meter to the 6 Newton meter to achieve some repeatability at some point. So, and the third objective is that the repeatability achieved for the BEMG under the torque range experiment. Giving a brief introduction of DEXA technique, it stands for Dual Energy X-ray Absorptiometry Test. It is a scan that is used to determine the density of bones to assess its strength. Bone blocks a certain amount of X-ray. The more density, the less X-ray it gets absorbed. So we can see here that the human is exposed to the X-rays, which is very harmful for them, and we cannot do this test many times in our lives. It has restricted number of attempts. So I am trying to develop a technique that is very user friendly, that has very less harmful effects on the humans, and it is based on vibration technique. It is not based on any exposure of any rays. This technique involves a PGT patch glued on an aluminum strip, as can be shown in the figure. This is the figure where this aluminum strip is of size 70 into 10 into 1 mm, and the piezo is placed in the middle of the aluminum strip glued through using of high strength epoxy aldehyde. This configuration has been clamped by using two Ghibli clamps, and here I eliminated the use of electrical strain gauges and the digital multimeter and the wires, of course, so that this technique could be more friendly and very easy to perform. I made the in the left figure. This is the position where I tied on the bone. This is the two clamps, and also this is the healthy bone, and this is the osteoporotic bone. It is made by digging a hole of 3 mm dia and 6 mm depth, so that a uniform loss of density has been resembled. After that, this is my experimental setup where I put the bone tied on a stand so that it could attain the boundary condition of free, and the bone BEMG, or known as non-bonded configuration of piezo sensors, attached to the bone, clamped to the two Jopley clamps as I discussed earlier, and tied it with the torque range. I started giving the torque from 3 Newton meter and to the 6 Newton meter. After doing the experiment, I found that at 6 Newton meter the signature has been stopped changing. They attain a specific benchmark, and after going through many multiple times of trials by unclamped the BEMG and then clamping again on the bone, I found these signatures and found that the coefficient of correlation and in the healthy bone is 99.99%, and the coefficient of correlation in the osteobone is 99.97%. So it depicted a very good repeatability, that if we tighten the clamps by 6 Newton meter torque, then it attain a maximum interaction between the bone and the NBPS or BEMG. These observations show that the BEMG is very much capable of detecting osteoporotic condition from the healthy one, because there is a right shift in the conductance signature of osteobone, this one, because when the bone mineral density has been dropped because of osteoporosis condition, then the frequency start shifting towards right, that is frequency has been increase because we have a relation between frequency and the density as an inverse relation. So frequency has been increased by decreasing the monumental density, and this picture shows very effectively BEMG captured the condition of healthy and the osteo condition of the bone. These are the concluding remarks that NBPH or BEMG shows very satisfactory result, and the use of DMM, that is digital multimeter, and electrical resistance causes eliminated by torque range. Repeatability has been established at 6 Newton meter, and we are planning for further enhancement of this process, and we are also planning for testing on live subject. One test has been done in our lab, and we are currently moving towards more tests, but the research has been suspended because of a wake of COVID-19, and will be resumed shortly as the things go on normal worldwide. These are my references that I've been referred while doing the experiments. Thank you to everyone who have given me the opportunity to present my work on this international platform. I am very thankful for the conference chair for approving my abstract, and I am very thankful to all the listeners. If you have any query, please post me. I will try my best to answer you, to clarify you on this subject. Thank you so much. Have a good day and have a safe health.